the whole world at our feet, watching seasons change. Our roads were lined with adventure, mountains in the way couldn't keep us from the sea. Here we stand, open arms. This is home where we are, ever strong in the world that we made. I still hear you in the breeze, see your shadows in the trees, holding on, memories never change.
Good evening everyone, and welcome to the second part of Windows kernel debugging with HonoraryBot, who I will switch to shortly. And basically, just a couple of reminders. The first part is already archived on YouTube, so if by any chance you did miss it, you can basically check it out on our YouTube channel. Apart from that, I will not be doing any mission reviews today, the solution reviews I usually do, nor any news. I will do a dedicated stream to it after the HonoraryBot series finishes, so that means in give or take 2 weeks. And there will be a mission today. There was a mission yesterday after the live stream. There will be a new mission today, as will be next week, and like on both live streams. So that's about it. And I would like to, without further ado, pass the microphone to Honorary Bot. Basically, get yourself a cup of tea and enjoy the show. Have fun.
Hi everyone, this is Artem Shishkin, also known as Honorary Bot. Yeah, and today we're going to talk about some basic stuff. Actually, it's not too much about kernel debugging, but it will include that. So it's more about actually WinDbg and the basic usage of WinDbg. So I don't know if you're like super advanced user, you might find it not so useful, but still, yeah, I've been asked to do a questions and answers session before I start, but I actually don't see any questions for now, so you have a chance to put them on chat right now, so you can answer it. And yeah, because there's a short time before I start to look at WinDbg. And before that, I want to remember like the yesterday's moment of stupidity of mine when I forgot how to set up a different key for the network traffic encryption. So we've looked up a command string for BSODs utility on MSDN, and it says we have to set up like dbg settings. Let's zoom it in. dbg settings, net, host port, blah blah blah. So we have to put in the full command. But what if I have already set the debugging settings, right? And I want to change only one parameter of it. So there is actually a special feature of BSODedit, which is called set. It can set only one parameter. And I said yesterday that this configuration data is stored in registry in the form of keys and values. So we have to specify a key, which is dbg settings, and then a parameter which we want to change. So it's going to be like this one. And that's it. And you don't have to retype the whole command. Yeah, and also one note I forgot to tell you yesterday about network debugging setup is that actually there is a parameter which is often omitted, but it is significant if you have DHCP. So you can enable or disable it. But if you disable DHCP, the interface you are debugging with is going to use an automatic IP address which starts from 169 and something else. So your traffic may be like omitted if you use some sort of network routing or something else. So yeah, basically if you have the DHCP server set up for your network, it works just fine. So I'm gonna check the questions again. And then I'm gonna start. Oh, no questions for now. Okay, then I'm going to start. So I'm gonna close the current instance of WinDbg and launch it again. Since I've set up the kernel debugging using the Ethernet or network, everything is already set up. Yeah, then I gotta choose kernel debugging. You see, there are a lot of options in WinDbg because it can do lots of different debugging stuff, including user mode debugging, crash dump analysis. So the kernel debugging analysis is just like a separate option. I got used to use shortcuts, so shortcut is Ctrl-K. And then we have a menu where we can specify the transport we actually use for kernel debugging, right? So I've set up the network, specifying the key, and it connects. Yes, it does. It says it is connected. to a target on a port, a local IP address, and yeah, this sort of stuff. And yeah, what I'm going to do now is to restart the target, but not yet. Yes, I'm going to restart the target and hit the Ctrl-Alt-K. This is a shortcut. We can also find it somewhere here in just a moment, or maybe not. I got used to using like the shortcut keys, so that's why I'm having a tough time to find it somewhere in here. Yeah, yes, I found it. So under the menu debug kernel connection cycle initial break, there is this sequence of keys. So what is it used for? My target is booting now, so you can toggle it on and off, and it literally says what happens when you hit it. It says it will break in at next boot, or it will not break in at next boot. It means that it will connect, it will gain connectivity to the target, but it is going to send breaking comment, or it's not going to send the breaking comment. And yeah, it is actually the earliest possible break-in. Oh, actually, I've broken in not into like the start of the kernel. It seems like I have set up on my target stand to boot in a Windows loader, which is a separate boot debugging mode, I'd rather say, but yeah, we'll just skip it and wait for the kernel. So the boot process on Windows consists of several stages. First, it's like firmware loader, but because of the fact that I have the boot menu with different boot entries, it transfers to to this menu, and then it starts WinLoad, which is specific to Windows entry. Yeah, and after the WinLoad, which is an operating system loader, we eventually end up in a kernel. Yeah, it's a kernel module. It has an alias NT, which in fact, the file, the physical file that is present on the disk is called NT-OS kernel or something like that. It has actually multiple names depending on the architecture, depending on how many cores you've got on your machine. Yeah, but for the sake of simplicity, WinDbg actually calls it just NT, no matter what exact kernel you have right now. So it's just NT. So we've broken in. It's the earliest possible break-in, and everything hangs. I also mentioned that since kernel debugging is a full system debug mode, everything stops. Yeah, that's the way it works. I'm gonna type in the first command, which is going to be reboot. It actually reboots the target. You can see it in here, right? It just takes a little time for VNC to refresh. And then I'm going to toggle it off, and you see what happens. Oh, it just on my face. Yeah, so it's gonna boot again. So you may find this command useful when using, for example, the breakpoints. We'll get to that like a little bit later, but still, yeah. So it's booting right now. Yeah. And first time we stopped here, I mean the last time the machine booted, we actually broke in. And now it didn't. It just connected, and the operating system just goes on. Yeah, so this is the way it works. And I realized that I've skipped a part that's, you guys asked me yesterday. It's about my current workplace setup. So let the operating system boot. I'm gonna log it in. It's logging in, right? Right? I guess so. So when you first install WinDbg, you might actually see it something like this. I'm gonna close all the windows. Yeah, and it will look something like this. So how do you end up with something like you just seen before I closed all my windows? So there are different views available in WinDbg. It's the command view. This is actually a console where you can type in commands, like to do some sort of different sorts of stuff. And actually, there is a command line version of a debugger, which is called NTSD or just KD, which is also available in the folder where WinDbg is located. And yeah, it's actually in this mode where when you have only the command window, it is just sort of a console interface. It is still can be used. It has no like limits, and it's just the graphical user interface is more pleasant to you. Yeah, so let's use them. Let's use the different views. So the next view is watch. You can type different like expressions in here, and they will be automatically reevaluated. And yeah, for example, I've typed in the RSP register. It is typed in with an @ assigned to notify the debugger that it's actually not a symbol name, and this is a register name. Yeah, and it says it's something like that. Let's check this. So where's RSP stack pointer? Where are you? Oh, here you are. Yeah, it seems to be exactly the same meaning. So yeah, the watch doesn't lie to us. It's good news. But I don't actually use it too much. Yeah, if you visualize a lot of data in different windows, it may actually affect the performance of your debugging session. And it is especially true when you use slow transport like USB to like serial transport without like those fancy kernel patches, virtual KD, and this sort of stuff. So keep that in mind if you happen to be on a slow transport. So the next window is registers. All the windows are dockable. You can place them however you like. And this is actually an interesting one. Sometimes if you do the kernel debugging, this window might be empty. Yeah, and when you click customize, it says, well, registers are not yet known, or something like that. In this case, there is a mismatch between the version of the Windows you are going to debug and the version of WinDbg. For some reason, there is such a bug. For example, if you like debug Windows XP in 32-bit version, I'd recommend you to use the WinDbg from the Windows driver kit for Windows 7, which is an old one, but it works just fine. Yeah, they all work fine, but there is a just register window glitch that might happen. I've seen it several times. But still, your registers will be available via the command window. Yeah, we'll get to that. What I want to show you is that this customize window, and it says, oh, here are the registers I want to show you. You can actually edit it and see what happens. Yeah, because actually I tried to edit them and nothing changed for some reason. But I guess it can work somewhere else. So the next one, registers. Memory. Yeah, it's quite useful window. I usually put it somewhere in here. Yeah, and it shows us memory. The scope IP is a pseudo register used in WinDbg, and it is actually an RIP register. Let's try it out. Yeah, it's the same value, but you can type here wherever you want to type. For example, like this, or pages. So I'm gonna type in this one. Yeah, and it changes. We can switch the display format. We can say that we don't want to auto fit the columns. Yeah, and it will align it in 16 bytes. So yeah, and there are also properties of this window where you can specify different types of memories actually. So the operating system uses the virtual memory, but there's also physical memory available. Bus data, which I'm not sure that works nowadays. Yeah, because the WinDbg has a lot of legacy stuff. It has like built-in extensions for Titanium processor. Yeah, for example. And yeah, they're still there, but they're not working. So I'm not actually sure if it works in here. Yeah, there is some control data, I/O, like I/O ports, and model-specific registers. Yeah, you can get all this stuff right here. The device. Oh, I've changed the device. View virtual memory. And I think I heard a question. So the question: can you have multiple memory windows? Sorry for my bad English. So yes, you can have them as many as you want. Yeah, and you can even put there like different addresses, and it will work. And it won't work because I've entered the invalid address. Yeah, but yeah, you got the idea basically. I usually keep one or two. So the next window is going to be a call stack. Yeah, why not? We actually need this one. It's interesting to see what's going on here. Like, what would be a debugger without a call stack? Yeah. So it automatically rewinds the call stack. Yeah, there is a catch about it. We'll get to it later. And the next window is disassembly. Yeah, the most important one. Like, this is the place we see our code actually. Yeah. And a scratchpad is just sort of like a thing you do the notes. But actually I've never used that. I use something like Notepad++. But it is there. And it might be considered quite comfortable to work with, but still. And we have some processes and threads. So the thing about this one is, if you do the user mode debugging, it is actually showing you the current process and its threads, right? But since we do the kernel debugging, the execution contexts are not the processes or threads. They are actually the cores of the processor. Got it? So my stand has 4 cores, and I can switch between them. All right, so this window is basically not so useful when you do the kernel debugging. And I heard a question. Hi Artem. Hi. I heard rumors about Microsoft porting Windows on ARM v7 or ARM v8. Will they release proper WinDbg to debug ARM kernels? All right. Let's get dirty on the stream. Yeah, actually they started to port it. As far as I know, it might be earlier. Yeah, there were earlier versions of Windows which were for Palm PCs. Yeah, those little, actually they were huge, so to say phones. Yeah, it was Windows CE actually. and there were ARM processors, so we can say that there were Windows kernels on ARM. But yeah, starting with Windows 8, they were kernels, and the whole OS actually ported to ARM devices. I actually have a Surface RT device. It's like, how's that called? I don't remember. So it's sort of an iPad, but with Windows on board. Yeah, the problem about it has an SDK. Actually, I'm gonna show you in just like a second. When you install Windows kits, when you open the debuggers, here it is, you see, it has an ARM folder. And actually, those are ARM executables, which may run on ARM devices. Yeah, but the problem about this, especially on Windows RT, is that it is forbidden to launch old-style desktop applications on it. Yeah, but there were sort of jailbreaks for earlier versions of Windows, which is Windows 8. Yeah, so the signature enforcement was bypassed there, and you could actually run desktop programs in it. And I managed to successfully launch WinDbg in there, and I actually managed to debug programs there. I'm gonna show you like a screenshot. Yeah, so it actually worked. You see, it's WinDbg on ARM. So yeah, so it's possible. And starting with Windows 10, actually they how do they call it, homogeneous kernel or something like that. Actually, you can run Raspberry Pi, the second and the third, and some other ARM devices, and you can run Windows 10 there, and you can actually somehow JTAG debug it. But I've never done that. I've never tried it, but they say it works. So yeah, basically, yeah. Perhaps it's too early to ask this question, but can I debug user space process from kernel mode, and how could I see what drivers are loaded in memory? You will see it today, I promise you. I'm gonna do it. So we've set up our windows, right? What else is interesting here? Yeah, and the painful part is the fonts. No, actually, it's not the most painful part. It's just the part when you can change the fonts, because yeah, if there is a default version of WinDbg, they're actually small, so you can readjust everything. It is actually, yeah, options. Yeah, here's the thing. So command windows, blah blah blah, workspace prompts. Yeah, workspace is a thing that keeps all your WinDbg settings. So it is your Windows layout, your symbol paths, your breakpoints. Yeah, and there's an option. If something happens, if an event occurs when your workspace has to be switched, it will always ask you, always save the current workspace, and never ask you and just discard all the changes you've done to your workspace, right? So these are the three options. Quick edit, I'm not sure what it does now. But yeah, here goes the most painful part. It's the colors, the background, and the text. So it is not enough to change those just to those lines, because yeah, there are so many different events, different backgrounds, and different windows that you have, I'd rather say, brute force these colors in order to your WinDbg look like this. And yeah, you guys asked me to share the workspace that I use. The problem about it is that it is actually kept in the registry. Yeah, here it goes. Here is the path. So it's current user, WinDbg, workspaces, explicit, which is the ones that you like explicitly save. And here is my workspace. Yeah, what I did actually is I exported this key, save it somewhere and just kept it in a registry file, and then when I set up the new WinDbg instance on a new operating system, I just imported the settings. The downside of it is that if you had some breakpoints set or some additional symbol paths which are set in your workspace, they're actually disclosed, and those are just privacy issues. But for today I tried to clean this up and put it on my GitHub, so they are actually available on my GitHub. So I saved the registry file, which might be useful for the earlier versions of WinDbg, because yesterday I realized that there is a new option, save workspace to a file, and it's just does basically the same. It dumps all the workspace data but in a separate file, but there were no options like that in earlier versions of WinDbg. So basically I've put on my GitHub both versions, a registry file and a workspace file, right? So you can have it on my GitHub. I hope I didn't leak anything sensitive. And sort of like that. And when I look at this setup of WinDbg, actually, I remember the tweet by Arthur Jerkis. I'm gonna show it in just seconds. He couldn't resist not to draw the analogy, and it kind of makes sense. You just look at this guy, but actually I'm not that cool as Arnie in here. I'm somewhere in between, so that's why I use actually a plugin called Big Lasagna. So the plugins for WinDbg are actually kept in a separate folder. I'm gonna have to reopen it right now in just a second. Windows Kids, debuggers. So there are different versions of WinDbg. It's x64 and x86. They are actually like basically the same. So there are no restrictions for x64 or x86 version. So but it does matter when you download some plugin, because plugins are just libraries, so they are just DLLs, and they can be assembled as x64 or x86 plugin, right? So the plugins are kept in this folder, WinExt, so it's extensions folder. And here I have this one, Big Lasagna WinDbg UI extension DLL, and the extensions are loaded like that. So it is .load Big Lasagna WinDbg UE, right, and it ta-da, and it's all like lights and colors and flashes. That's cool. So I've put a link to this plugin. I've actually put links of all the plugins I currently use on my GitHub, so you can find the link to this magic plugin in there. But there is a catch, actually. The default plugin configuration actually doesn't colorize you this window. It colorizes the command window, because you can disassemble right in here. So it's gonna be colored in here, but not in here. But you can ask actually author to recompile this plugin for it to colorize this window. So it should be no problem. What's next? I've told you about the workplace, this sort of stuff, the plugins. Right, I guess I can move on. Those options are really irrelevant in here. Then we're going to proceed. It's frozen. let's move to, I guess, some basic commands. So the first command is breaking in. So there is a keyboard shortcut which is Control Break. And yeah, I got unlucky because my keyboard actually doesn't have a break key. So I'm used to just click this button. Yeah, we can actually look them up. So the first one is break. This is how we break into our target, and the target freezes. Yeah, so it works. And now we're able to type in some commands like go, which means go away from my site. And the debugger starts to run away from you. Yeah, just like that. So while it's running, you can do any commands, right? Just like the regular user mode debugger. It is just the same. So yeah, the next basic commands are T is for trace. It means step into. The shortcut is F11. Yeah. Where's the call? I want to see the call. I want to make sure that it actually steps in. But I got stuck in a loop. Really? Please call. Oh yeah, I'm going to call. So I'm going in. Yeah, it works. And the other command for stepping is P. It is step, but not stepping into it. It is called step over, I guess. So it will just ignore the call, and the shortcut on the keyboard is F10. Yeah, it just ignores that. So it is basically, I guess, it for state manipulation. Yeah, there are some extended commands. We'll get to them in just right a second after I answer the question. So the question is, why don't they mark 32-bit and 64-bit with alright, why don't they mark 32-bit and 64-bit with 32 bits in their assembly in WinDbg? I'm not sure what you're trying to ask, actually. Could you somehow rephrase the question, because yeah, my psychic powers are not that strong. Yeah, so I'm sorry. Could you please retype the question? Yeah, so the state manipulation. I've already shown you a command which is reboot, and it is going to reboot your target. As simple as that. So yeah, we've used go, steps, like reboots. Yeah, the other command that will change the state is actually switch the execution unit. So if you do the user mode debugging, this command will switch you the thread, the current thread. But since the execution unit is a core, a processor core in kernel debugging, we're switching the cores. So we're going to switch to the first core. And we see that it is somewhere in Intel ppm driver. Yeah, it does something like basically nothing because it is stuck in a function and wait idle. Yeah, it happens to the processor all the time if the Windows is not too heavy loaded, and right now there is nothing running. Well, almost nothing. So let's switch to the other core. It's the second one. What is it doing? The same, nothing. And this one, same, nothing. They're so lazy. Yeah. And the 0 core, which was the active when I broke in, is actually inside the KD transport library, which is network interface card, because I use network for debugging. Yeah, and it is some sort of doing the packet transmission. Yeah, right. So the thing about breaking in is that we break into a random space. Like every process process on Windows has its own separate address space. Yeah, but the packet polling for breaking in, you know, the timer in Windows ticks, right? It has the context switches, it switches the processor, processes, and on, right? And between the switches, it actually checks if there is a packet that requests break in. So it happens randomly from our perspective. So when we break in, we're actually in a like random process basically. Yeah, but here goes the next part. All the comments you've seen so far, except of view memory, which I'll show in a couple of seconds, do not depend on debugging symbols. You know, earlier versions of WinDbg actually said in its like title that it is actually a symbolic debugger, so it has to be used with debugging symbols, right? So we can actually step code, we can actually like change the state, everything's fine. But suppose the symbols are not loaded. You can see the names of the functions and models right now because my workspace actually has a symbol path set up, so it automatically loads the symbols. But suppose there are no symbols. Load. Symbols unloaded, right? Oh, reloaded the symbols. It's just me being stupid. So yeah, it just basically sees the assembly and nothing else. So we don't know what the current module is, or yeah, we know nothing. We just see plain assembly. Yeah, I promised the comments that showed the memory. And it's just a second. If you break into the system, is the processor context always in kernel mode, or it's possible to break when the CPU is executing in user mode code? It is possible, but give me a second, I'll show you. It's just, yeah, actually the display command is very common and it is very useful, so I'm gonna just show you and then proceed to debugging symbols. So the command is called display, and we can display in different flavors. We can display bytes, we can display words, we can display double words and quad words. You got the idea, I guess. Also, there's a magic command which is display quad words with, oh no, it's too early for this command, I'm sorry, just forget it. Yeah, so, and actually there is an equal command which is E, means edit. You can edit bytes, you can edit words and words. So it is used to like modifying the memory. Actually, you can modify memory just right in here, for example. Yeah, and I just modified the code. I shouldn't run it further. Yeah, and then I fix it. So yeah, the most important part, we got no symbols. We got plain assembly here. What do? We use the debugging symbols, which are stored on Microsoft servers. So the command for setting up the symbol path is sympath. And basically, where you get your path is you do the Google. It's the most efficient way, actually. So the Google, and you type like sympath MSDL, which is start of the name of a Microsoft debugging symbol server, and you got like something like this one. So SRV symbols, blah 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 blah. Yeah, you type it in. Yeah, but those symbol paths are actually cached in your workspace. So if you set up your symbols properly, and if you save in your like workspace, then you don't have to do it all over again. So, but just for sake of demonstration, I'm gonna type, oh, there are actually some problems with symbols in this case. Yeah, so SRV, and just copy and paste it. So SRV like denotes the server, and the next part of it is your local symbol store. It's like if there is a symbol in your local folder, it will load it from a folder, but it's not there. It tries to like query the Microsoft symbol servers and download it from there. I got a D drive. After you've set up the symbol path, you can actually type reload, and it just loads the kernel symbols. Yeah, we'll check this one. Yeah, they're right there. And ever since you've managed to load the symbols, you now have a really powerful tool to debug and actually reverse engineer Windows. Here's why. There are a lot of extensions in WinDbg. Yeah. And they usually start with exclamation mark. I'm sorry, I hit the F1. Exclamation mark. Many of the sources say that it is pronounced as bang. So it's bang process. Bang thread. Oh no, I'm not going to enumerate all the threads. Yeah, it's bang PTE, it's bang, I don't know, PB, so PB is null. Yeah, that's for sure. So bang, bang, my baby shot me down. Yeah, so this is what we're going to use now. But before that, I want you to really memorize the following command, because it's like, it is, without exaggeration, it's the most important command in WinDbg. It is called .cls, and it clears your output. Very useful, because there's like so much output out there which may confuse you. Yeah, so I do CLS all the time. Quite useful. So we can see the current running process just like that. We type in bang process, and it starts to show you what's going on. So I'm gonna scroll it up. How do I scroll it up? Yeah, it says current process is this: session ID none, PB parent SIP, and the image is system. So it is actually like a pseudo process. Yeah, it is process 0. Oh no, it's process with process ID 4. You can actually like view it in your task manager. So it is right in here. It's called the system, and it's just basic system process. It's just like a container for just, you know, it's just an address space which is used for system purposes. Yeah, it is, for example, used for scheduling the kernel threads. Yeah, they live in this process, and they are considered as a part of this process. Yeah, so back to the question I just had right in there. Will it always break in the kernel, or it might also break in user process? It can break randomly, but yeah, you know, because there is nothing going on here on the system, it will certainly break in the kernel space. You know why? Because it is having a rest, and yeah, in this case it is breaking in a system process, because it is where the packet polling for kernel debugger happens. Yeah, and it is done in kernel. But yeah, if we look at the other cores, they're actually doing nothing. They're in an idle state, and it's the state when they're actually in kernel mode. So yeah, most of the times we'll break into the kernel mode. But yeah, if I, for example, launch some program, Yeah, if everything works on this target, because yeah, works so slowly. I'm gonna check. Oh, there are no questions actually. So, come on, guy, what's wrong with you? Hey there. Please launch the file explorer. It wants me to set up some driver. What do you want from me? Well, it's lagging a bit. Yeah, and while it's lagging, I'm gonna look up the following question. Dumb question. How to find anything useful in all those thousands of lines of assembly? Anything useful? It depends on what you're looking for, actually. Because, yeah, actually, if you debug something, for example, some driver, you can actually debug it in a source mode, because WinDbg actually allows to do that. It will open like your source code, it will fetch your symbols, and it will like debug in terms of lines of code actually. Yeah, so it might be useful. It also might be useful when you like trying to exploit something, because exploits are commonly like depend on these small steps, which is done in assembly. Yeah, and here is when the assembly mode actually helps. But yeah, if you're just like walking through the core, you don't have to put your efforts to understand everything what is going on there. There's really no need for that, right? So, well, sort of, it depends. My popular answer for the question is it depends. What I'm trying to do now is to launch some heavy application. For example, yeah, I'll launch like several instances just to make sure. And I'll try to break in. It is broken in somewhere. Let's see where. So what's the current process? And the current process is exit delay. This is just that process that I have launched, right? Let's check the other cores. Yeah, and see the stack. It is actually, there was interrupt. I'm not sure which one, but I guess it's the timer interrupt. And then, as I said before, while it reschedules the threads, it actually checks if there is a break-in packet. And yeah, we see that it checked it and broken in. Yeah, let's switch the core. The next core, yeah, it's actually in the user mode. You can see that because like the addresses are in the lower part of the address space. Yeah, we're gonna talk about address space like next Wednesday, I guess, but for now it's just that if there are zeros in here, then it's a user mode address. If there are like Fs in here, then it's a kernel mode address. Yeah, and you see, we've switched to a user mode process, and we see no symbols. And we don't even see the stack, because stack on x64 systems is rewound in a different way. It's not EBP frame based. The stack unwind goes through the special section, which is pdata. It stores the exception rewind info, and yeah, without symbols, it can't even like unwind the stack. So if you switched the state of a debugger, for example, if you're in a different address space, you have to reload the symbols again. And we'll see what happens. Yeah, it says that the current module is exit delay, actually. Yeah, but I don't have any symbols for it now, so the stack is not unwound. But still, yeah, it says it's the user mode address, and we can actually like step the code here, right? So yeah, something goes on. Actually, there is an endless loop of CPU ID instruction, right? So yeah, we can actually not only step the kernel code, but also the user mode code. So it works just fine. Yeah, and actually there was it was an answer to a question that I seen there, right? So yeah, the break-in is random. But what if I want to like debug, for example, a command prompt? Let's do this. Let's do the bang process with parameters 0, 0, and it will dump all the processes that are active on the system at the moment. Yep, so we see that there is a process kernel object in here, and the image is CMD, which is command prompt action. So what if I need to debug this one? But currently I'm in a system process, I guess, by judging by the count of the threads it has. Yeah, because system has a lot of kernel threads which do different kind of stuff. Doesn't really matter what. So I need to break into a different process. So as you might remember, the system is frozen now, and this process has actually a different address space. It is denoted by the directory base. The directory base is like a term of Windows. It is actually a physical address of the root of the page table. We're going to talk about virtual address next time, but still. This is the magic value which starts describing the process address space, right? So we're in a different process address space and we got to switch into it. And we can do it like that, dot process. Then we specify the process object. And yeah, and we need a parameter, which is I, interactive. And it says, whoa, yeah, sure, but we need to continue execution. And that actually makes sense, right? Because the system is halted now. We can't just switch to this process, so we just request the kernel to freeze once we switch to the address space of this process. And this is what happens. We're gonna have to reload again and type in the process. And we'll see that it is now cmd.executable, right? So, moving forward to different tangents. So, somebody asked if I can see the modules. Yeah, actually you can. It is done via the command list modules. And it enumerates the modules. And because of the fact that we're actually doing a kernel debug, it shows us not only the user mode part of the modules. See that? Right. It also shows us a kernel modules. And like from this perspective, we can say that kernel modules are actually drivers. Like mostly those are the drivers. We can actually find we can actually find like a kernel image in here, right? In just a second. Well, actually, I'm gonna show you a new cool feature of WinDbg. Since it's the like rich edit control or something, there is a Control F and TOS. Oh no, it's not in TOS. In T kernel multiprocessor, something like that. Yeah, right. And we see that we got NT module in here, and those are mostly the drivers, which are loaded like in a runtime while the system boots. And also we got here hardware abstraction layer, DLL, which is used for fitting the kernel to a specific hardware, right? We got a like AD library, which is used for our transport. You got the famous Win32K module, which holds the graphics subsystem of Windows. I guess you know what it's famous for, but still, yeah. And here it shows that, yo, I've loaded the symbols. They are right there, just in case you forgot it. Yeah. Still, I heard some questions. So, how many years doing reverse engineering? And me personally, I guess it's more than 10 years for now. But I'm not that strong reverse engineer, actually. I suck at reverse engineering. On hacking again, could you go and edit userland's process memory this way without other userland security software like Valve anti-cheat noticing it since you didn't open a handle? Well, yeah, you can actually, let's try it right now. We're in the CMD process right now, but what do I edit? I guess, well, it won't be like a nice example because there is no output for now in CMD. But yeah, still you can edit its memory, and to do that you have to know the memory layout of the process. You know that not all virtual addresses are mapped in the process, so you have to know about the address space. And here comes the extension which is called bang address, and it shows us the ranges of memory in the context of the current process, both userland and kernel land, right? So it's going to take a while to map kernel regions. But yeah, for example, oh, I got another idea, but still, I'm gonna show you that. Yeah, there are a lot of user ranges, like process environment block. Yeah, let's take the process environment block. Where is it? Is it this one? Display bytes. Yeah, it looks like, yeah, something like that. We can also bring it in here, and we can actually do this, right? So you can edit userland memory with no problem. But yeah, the second part of the question is, will Valve anti-cheat notice it? Well, if you do the patch, it will be noticeable, right? Because you're changing someone else's memory. But actually, generally speaking, it depends on the method which Valve anti-cheat actually use to detect the changes. Yeah, because if it just counts CRC or some other checksum on this region of memory, like every second, then yeah, it will see the change, right? Because how would you change something without changing it, right? So yeah, it depends on the method, basically. And also I would add that kernel debugging, as any other type of debugging, yeah, there were like a couple of streams ago on this channel about anti-debug. Yeah, so there were anti-debugging tricks. So kernel debugging also changes the environment that your system runs in, and there are several ways to detect if your system is being kernel debugged. Yeah, you may look them up somewhere else, but yeah, there are. So you can actually detect with even from the user mode. Like there are some events like KD sleep timer. It is like an event which shows that time has slipped while you were halted in the kernel debugger, right? So something like that. So it works. Another question. Hypothetical question. Could they, Microsoft, move Win32k back to user space with the current hardware speeds? They actually could, but you know, yeah, it would drastically change the architecture of the graphical subsystem from my point of view. Yeah, so I don't think it's possible just like fast enough to be applied. Yeah, because you know this component is more than 20 years old and it is still not replaced, so there might be reasons for that, right? So yeah, and the actually performance penalties are not coming from the hardware. They're actually coming from the way Windows schedules the threads. So you suppose you're moving the graphics subsystem into a different user mode thread. So if another thread, like sets the highest priority on the system and the other threads are starving now, your graphical user interface thread will like die out. Yeah, it will starve, and you will experience huge lags from redrawing the things on your desktop, for example. Yeah, but it's a hypothetical question. It mostly depends on the architecture. But yeah, in the current architecture, I'm not sure that it's possible. So, couldn't you use DMA to edit some process memory? Yes, you could, but yeah, it's a whole different story because yeah, when we edit a memory, a CPU involved in it. Yeah, but DMA is sort of different stuff because CPU is not involved in it. DMA is used with different hardware, right? Yeah, but there is a trick which is called IOMMU, which is Memory Management Unit for IO devices. So it's a special feature which implemented in a chipset, right? And both processors and chipsets have to support it in order to get it to work. Yeah, and I'm not sure about Windows 8 or 10 if they use this feature, but I know that Mac OS extensively uses this feature. And basically what it does, it has a separate memory mapping system. So it has page tables that are used for the hardware, and they just tell where the DMA can go and where it can't. And they say like, hey, it's an operating system memory, you can't DMA into it. I guess Windows will not allow you to DMA in this memory region. I guess, yeah. I start like to remember that I tried that, yeah, and I failed. So basically there are protection for that. Yeah, so it's cool that you ask so many questions. Yeah, I'm glad to answer them. Well, we were talking about address spaces, right? So yeah, you can change it with no problem. But yeah, about the part of reverse engineering this stuff, we've loaded the symbols, right? So there are some operations that you can do with the symbols. Remember the module NT, right? There is a command which is X, examine symbol. And we put a module name, then an exclamation mark, and for example, a function name like NT create user process. And it says, it looks up the symbol in a loaded symbols file, right? And it says, oh, this function is right here. Let's try and see if it's really a function. Yes, it is. Here's the prologue, right? And there is a feature of this command. Actually, you don't have to specify the full name of a function. You can use a wildcard, right? Oh, what am I doing? I've broken everything down. Yeah, because there was a key pressed on a different. So yeah. Okay, NT create, and you see it shows us multiple functions. So this is how usually the reverse engineering process of mine happened. I sit and try to guess the name of the needed function because, yeah, for example, I want something that has to do with process. So I type in X and T, and since NT is the kernel of an operating system, everything operating system related stuff is there, right? So I need something about process. And whoa, this is such a great list, right? And there are not only functions in here, right? It says no parameter info, no type information, right? So they're not only functions, there are also like variables in here. Let's see, for example, process head, I guess. Kernel internal process list head. Let's try this one. So you might realize that there is a special structure in the kernel which holds the list of a process objects, right? And I guess I don't have to remember it, right? I just type in process list, and I guess it's key process list hat, and then I look it up right in here. And from here, there has to be a pointer to a process object. And this is where the other feature of WinDbg comes in. It actually called display type, DT. It scans the structures from the symbol file and it shows it to us. And the wildcard also works with that. For example, I need to look up the process structure, right? And it says, yeah, here you got the process structures. So, for example, let's output this structure. And here we see the output, which denotes the structure of the process object, kernel object of key process, right? So it has some fields like PCB, process log, active and active process links. So here I have some value, right? But it's not the start of an object, right? I can't map it directly to the structure. I need to start it from the offset. And the WinDbg has a cool feature of evaluating stuff in here, right? So I see that active process links are in the offset of 2 echo 8, right? So what I'm going to do now is like, it has to be a link, so I have to subtract it, right? So okay, let's try this one out. Display type and TE process at this pointer. Did I guess it? Did I guess it? No, I didn't guess it. There's something wrong because image file name is invalid actually. So yeah, let's try in a different way. I'm not sure like this is the thing I really need to. I have to dereference it once more. Let's try this one out. Yep, let's try this one out. Display type, eProcess. Image file name H. So yeah, basically I'm doing something wrong because it might be not just active process links, right? But they seem to be like pretty fine actually. Let's check the other flags. Check randomize disabled. No, unique process ID is invalid. Yeah, so let's do it in a different way. So there is an extension which is called BANG PCR, which is processor control region, and it shows like you got this thing that is called thread local storage or thread environment block on Windows. This is something very particular to execution thread, right? So it's exactly the same thing, but for the processor core. So yeah, it maintains some info. For example, like stack base, system of clip, and I need this one, processor control block, actually, PRCB. Can't get the RCB address. Oh, sorry. Yeah, but it doesn't show us like. Oh, actually, it shows us the current thread. This is actually how the kernel defines the current thread. So let's check this one out actually. So nt ethread, and yeah, the structure is mapped just right fine as far as I could. Yeah, active timer list hat. This is the way you actually reverse engineer it. By examining the structures, you get to know what's in there, right? So I already see that it has start address, which is a kernel mode address, so it's a kernel mode thread. we can type in examine address, so to ask the kernel debugger to look up the address in the symbols. But yeah, since the symbol for the very particular module is not loaded, it doesn't show us anything. Yeah, all right, that's fine. So yeah, about the process list. So this extension, basically how it works, it walks through the list, which starts from the variable that I showed you, which is TI process list head. It just oh yeah, let's actually find out what I was doing wrong. Let's just remember this one, and let's again do this. Because the process list starts from a system process, because it's the first process that appears in the system, right? So, oh, I got too far away. Oh, actually, oh no, there were no questions. Process list head. Does it look like anything? Yeah, it just I misplaced the offset for some reason. Right, so let's see what the real offset was. So the real offset is 238. What did I do wrong? Why that stupid? I subtracted it, right? Just a second. Process. So 238. 200 and oh no, I used the different field for that, right? Yeah, it's not the field that I was supposed to use, right? So what's the real field? So it's a complex structure, and we can actually look up what's inside of it by typing dt and t e process r minus r. So it stands for recursive, and yeah, there's quite a lot of output already in here, so I'm just going to use the famous clear screen command and look it up again. So there is another structure, this k process, blah blah blah. Let's find the actual link. The process was 200 and 38. Where is that? Affinity? No, it's not that. Not affinity. It's the other structure. Yeah. So somehow I fail again. Yeah, it should be active process links. I guess I did something wrong with the math. But yeah, traversing this list, you can actually look up all the current processes. And this is actually the way the extensions work. They are like rely on the symbols that are actually loaded right now. So yeah, about the extensions. Well, the most important part, I guess, it's the breakpoints, right? What do we use the debugger for? It's used for the breakpoints. So there are several types of breakpoints available for kernel debugging also, but there also work on user mode debugging, right? So it is breakpoint. It's just breakpoint. For example, let's step somewhere. For example, I pick this address. So the common breakpoint sets a breakpoint on the address. You can actually type BL, which stands for breakpoint list, and it will show you the list of a breakpoint. What you can do about the breakpoint, you can disable it by specifying this ID, right? And here it says that it is disabled, and you can switch it back on by typing breakpoint enable, and you can breakpoint clear, right? so there are no breakpoints anymore. You can actually save the breakpoints in your workspace, not to reset them again. Yeah, so breakpoint, where did I set it? So let's try it. Yeah, bang, and it stopped right here. So I guess this works. Cool. So you can also use a wildcard to remove all the breakpoints. And there is also another way to set up a breakpoint, which is called break unresolved. And okay, I feel the difference. I'm going to set up right in here. It looks like that there are no difference for it, but I'll tell you what the catch is. The catch is that the usual BP sets a breakpoint and binds it with the virtual address, right? And when you, for example, reboot your target, it loads up again and bang, your breakpoint doesn't work. You know why? Because it is set on the address. But if you use Windows Vista or later, there is such a thing as ASLR, which is address space layout randomization, right? And your model, where you intended to put a break on, is not there anymore. It's loaded in a different place. And so it cannot set a breakpoint there if it's using a virtual address. So another way of specifying the breakpoint is unresolved. If you specify it as break unresolved, it will treat it not as a virtual address, but as a module, function, and the offset. Not really a function, but the module and the offset. So next time when you reboot your target and when it loads, it will look for the int module and use the offset for setting a breakpoint. And that's how the way it works. So basically, most of the time, you're going to need the break unresolved, right? So, yep, it works. Everything's fine. There's also a keyboard shortcut, which is F9, which allows you to set breakpoints right in this view. Yeah, it might be quite useful. So, yeah, there are also so-called, oh, where am I? PS quit next process. What is this all about? So the next is actually hardware breakpoints. Those are the breakpoints that work with debug registers, right? So debug registers are context specific. So if you set a breakpoint on a linear address, it won't work anywhere, because yeah, every thread has its own context, and the debugging registers always reload when you switch your context. So this actual breakpoint will only work in the context of a certain thread. But yeah, there are only 4 of them, like dir 0 to 3, and actually, yeah, they might be used for like setting the execution breakpoint, but they're not used for that, mostly because the special feature of the hardware breakpoints is break on access, which is what I'm going to show you right now. So we got here an instruction which is going to write something to this address, which is RSP +10. Let's evaluate this. So display words RSP. So I guess it is going to touch this one, and we say break on access read. Oh, it's not going to be a read, it's going to be a write. You can just break on access, yeah, break on write, and you have to specify the size of an access, which is going to be 8, right? Let's look this up. So it seems to be set. So we're trying to execute it now. Yeah, and it stopped right after this breakpoint. So this is the way it works. It actually stops right after this. But at least it works, and that's a really cool feature. Yep. So clear the screen again. Okay, so I'm trying to remember what I could forget. So we got the basic command. We got the display memory, edit memory. Display the registers is just type R, as simple as that. You can actually change the registers in here or change the register with the R command, like for example RIAX register. What's that? It's 10. Like RIAX equals to 100. Has it changed? Yeah, it seems to be changed. So we are going to change it back. Yeah, one other useful command is formats. We can specify some value in here, and it will display us it in different flavors, like decimal, octal, binary, like characters, and this sort of stuff. It's useful for conversion. Yeah, so display, state modification. Yeah, there is also a cool feature about state modification called step until the next call. You can actually step the code from call to call. Yeah, and this is also the way I reverse engineer the stuff, because yeah, you know what the function does. So you don't have to reverse engineer all memory moves. You just can follow the flow of the function calls, right? So its feature might be very useful. Yeah. So there are also some sorts of stuff for hardware debugging, but I guess I'll talk about them in a week when we will talk about the hardware and the physical address space. Yeah, the extensions. Yeah, one extensions I wanted to mention. There is a scripting language built in the WinDbg. Yeah, and it is sort of not easy to write something on. So I really recommend you to use an extension which is Python KD, PyKD, and it allows you to write scripts in Python while kernel debugging. It might be really useful. Yeah, I've used it several times. Yeah, but the last thing I'd rather show you is this scripting language example. I'm going to set a breakpoint. And this is a bracket that says that I will do something when the breakpoint is hit. So when the breakpoint is hit, I want to type these exclamation marks and say go on. Yeah, and there's a syntax error. Yeah, and it goes all the time because I rarely use it. Okay, so WinDbg script. Oh yeah, actually a small advertising about WinDbg. It has a really nice help actually. So block delimiters, statements. So I'm gonna just look it up, the breakpoint command, right? Set breakpoint, and here are some examples of what you may do with a breakpoint. Yeah, but it shows no passes. Oh, a command string, so it's not used for. Yeah, right. I guess it will malform string. Am I missing something? Oh yeah, yeah. The problem about this is this one. So yeah, we have a breakpoint with some assigned actions in it, right? So let's try to use it. So I guess it should work when you launch a new application in it. Yeah, here it goes. I launch the command prompt and it actually fires 2 times because it's a console application, and for every console application there are 2 executables. One is the main executable that you launch, in this case CMD, and the second one is a console host, yeah, which do all the dirty console work for it. So yeah, I guess it's already a little late. Yeah, I guess I've been talking about all the basic stuff. Yeah, and I'm actually ready to hear some questions from you. Yeah, and I'll be glad to answer them. Just like that. I'll look up the chat actually. So yeah, actually I don't see anything for now. A lot of you guys actually died while watching the streams, I guess. Yeah, it was a little boring. Sorry about that, but yeah, it was just the basic stuff actually. So, are there any kernel challenges planned? Not at the moment actually. Yeah, I know that it might be interesting to exploit, like how's that called? Axis extreme vulnerable driver, for example. Yeah, it is actually some pretty interesting stuff. I'm gonna switch the camera, I guess. Yeah, but I'm not planning it yet. Yeah, we'll see in future actually. So yeah, like that. So what is planned in part 3 and part 4? You mentioned hardware, drivers. Not really the drivers. The part 3 is about Windows virtual address space, and I have actually a plan for it, and I can read it out loud. So what's inside? Well, actually this is sort of a stupid plan, but still, what's inside? Modules, heaps, stacks, PEEP, TEEP, shared user data, NLS, and the kernel space like KPRCB, KPCR, hyperspace, PFN, database, session space, modules, pools, system PTEs. Yeah, this is what this was a brief third stream actually. And for the fourth stream, I'd like to talk about physical address space. It is more hardware based. I'm gonna talk about what resides in a physical address space, how do virtual addresses translate into physical ones, like what's the firmware, what's inside in it, what is chipset, and what is it, and what the devices are inside it. I'm gonna talk about ACPI system and like PCI devices, how you can harass them actually. So if dbg print is called, where is it output? So it won't, there will be no output by default. Yeah, because early driver developers, like back then 10 years ago, used to spam a lot with these debugging messages, so they are now filtered out by default. So you're gonna have to like turn on the verbose output, and it will then appear here in the command window as a log. Yeah, but by default there is no output. You have to modify some kernel variables for that. So yeah, thank you, great stream. Oh, thank you. You liar. Yeah, no, really, thank you. Will you touch on the subject of IRQLs and DPCs? Yeah, they're actually more Windows related, and I can actually write about it. If you want, I can mention about them, IRQLs and DPCs. The IRQL is more like a hardware bound thing, and DPCs are actually, this is a part of Windows architecture. Okay, I'll do this next time. Yeah. So in which cases would you use WinDbg, and what cases you would use something like x64 dbg or some other debuggers? All right, I'm using WinDbg Okay, I'll start it like that. I used to use only DBG, right? Because it was super cool. It was lights and shines all over the place. I really learned reverse engineering by using it. It was cool. Yeah, but it was 32 bits only. So when the 64 bits operating system came in, I couldn't use it anymore, so I started using WinDbg, right? And then I just got used to it. I like do the things rather quickly with it. Yeah, so yeah, I use mostly it, but I really like x64 DBG. It is like, it's brilliant. Well, very well done. Yeah, but I'm used to WinDbg, unfortunately. So also there is no real alternative to WinDbg when it concerns the kernel mode debugging. Actually, yeah, you have no other tool to use it for kernel mode debugging, so it's like the only reasonable choice. Okay, some other debuggers. So it's just basically a matter of taste, unless you don't have to do the kernel debugging. Do you prefer to set symbols in WinDbg itself or NT symbol path? Okay, NT symbol path is an environment variable which you may set. Yeah, but it is screwed all the time. I've tried it several times, but it always breaks down. I'm not sure why. The environment of a specific process may change, or like specific user might like change, or something might override it. So I prefer store it in WinDbg and save it in the workplace. So when the kernel debugging fires in, the workspace automatically loads it, and I don't really have to do anything about it. So it happens automatically. Yeah. So is it too large of a question or out of scope to see how Windows handles privilege escalation? Okay, I can like describe it briefly. When you exploit something, the final phase is to do the escalation of privilege is to actually, yeah, just a second, I want to show you what happens. So you got this process object, right? For example, come on, stop. This one. You say display type NTE process, and this one, CLS, one more time. And then somewhere in here there is a process token, primary token frozen. Yeah, it has an object which is token. It's there are security related like descriptors and everything like that. So basically what happens when you elevate your privilege, you take your process, you take its token, and then you override its token by a token, for example, of a system process. This is how you get the system privilege. So briefly, it works just like that, right? So yeah. Does WinDbg have some auto-exec possibility, e.g. to run a Python script when WinDbg launches, or run a script on an event like target attached? Yes, it has a scripting language, which I sort of showed you, because you saw when the breakpoint fired, it actually executed the string that I like specified to it. Yeah, but there is also a plugin which is PyKD. Oh, let's try it. Oh, it loads. I'm not sure how it starts actually. I don't really remember. So so I don't remember. Sorry about that. But you can like Google it up. I got the link on my GitHub. Yeah, and there is actually a source code and a very clear documentation of what it can do and what it can't do. Yeah, it was PyCMD. I just forgot it, right? So once you fire it up, you can like use it as a basic Python interpreter, right? So yeah, like that. Yeah, and it has some like events, and it may react to certain events. Yeah, so yes, you can. Any more questions? I'm not seeing them right now. So yeah, I assume that's it for today from me. Thank you very much for coming. I hope you found something interesting on this stream. And yeah, see you on Wednesday, and have a good evening. Bye. Yeah.
Okay then, so that's about it. Thank you, Honorary Bot, that was awesome. I really enjoyed it. And I learned quite a few things, like for example dot formats, like where was this command all my life? I guess it was verb, but I just didn't know about it. So again, the mission, if you're waiting for it, will show up at, well, in a few seconds. Apart from that, I would like to invite you to next week, both Wednesday and Thursday, same time, which is 8 p.m. Central Europe time, basically, summertime. And there will be the part 3 and part 4 of Honorary Bot's Windows debugging series. Apart from that, I would like to add that part 1 is already archived. Part 2, the full video will show up on YouTube in like, I guess, 15 minutes after the stream ends. And all the links which were passed today and on the last stream are actually in the description under the video. So again, thank you for being here, thank you Honorary Bot, and I wish you a happy evening and basically happy hacking as well. Happy trying out what you've learned today, and see you next week, and good luck with the mission. Bye bye, and I leave you with some music.